Okay, this is exercise set 1.2. Its title is Systems of Linear Equations, 2 variable, calculator solution using the graphing feature of the TI-84 Plus calculator. We're encountering single point solutions in these exercises. Okay, let's take a look at the instructions here for these. Part A, is the system linear, 2 variables? If not, state this and explain the reason. If so, proceed to answer parts B and C below. B. Solve the system using the graphing feature of the TI-84 Plus calculator. Record what you have entered into the y equals edit screen. Record exact answers if you are able to by using the calculator's fraction conversion feature. If not able to do this, explain the reason, and then record decimal approximations rounded to 3 significant digits. C. Use the calculator to perform an algebraic check of your solution. Record the result. Exercise 13. Alright, is this a linear system, 2 variables? Looking at the first equation, has the form ax plus by equals c. That's a linear equation. The second equation, it has the form ax plus by equals c. That's a linear equation. Alright. Part A, yes. This is a linear system, 2 variables. Okay, this brings us to part B, where we're trying to solve it using the calculator. Alright, to do this, we will need to solve graphically, get y solved for in each case of these equations. This first equation, we could subtract 211x from both sides, divide both sides by -1, and then divide both sides by 319. The end result would be a y sub 1 equaling 211x minus 22 divided by 319. Second equation, subtract 74x from both sides, divide both sides by 187. We have y sub 2 equaling 117 minus 74x divided by 187. Alright, we're ready to go to the calculator. Here at the calculator, we can go to the y equals 2 edit screen, and in y1 we can put our formulation, parenthesis, 211x minus 22, parenthesis, divided by 319. Okay, let's go to y2, for which we have developed parenthesis 117 minus 74x parenthesis divided by 187. Okay, we can take a look at a standard coordinate system by doing zoom 6. Okay, an intersection appears immediately on this coordinate system. Great, that'll be our one and only solution. By the way, we know there are no other solutions because graphically each equation has a straight line graph. That being the case, since they intersect as they do here at this one point, they are not going to go on and intersect again at another second point. Okay, so let's go ahead and calculate this. Second, calculate, intersect. Alright, I'll move the calculator cursor a little away from the congestion, and that looks like indeed a good first curve for us. Enter. That's our second curve. Enter. Let's make a guess about there. Okay, now let's see if we can't get some exact answers from this. Back to the home screen. Let's take a look at x. Math, fraction conversion, enter. Okay, we seem to indeed have an exact x there. How about y? Alpha, y, math, fraction, enter. Oh, okay. The calculator has just returned the decimal approximation. No rational fraction conversion in this case. Alright. Well, let's record the answer that we have on the paper. We are able to write that the approximate solution is, now the x-coordinate we're able to record exactly 3767 over 5733. Now this y-coordinate, we'll need to round this to 3 significant digits, so that's 0.36, and then 6 is the result of rounding there. Okay, our conclusive statement. Now, since we did not provide an exact solution, at least in both coordinates, we need to do a little explaining here. Alright, we look at this original system, and we can notice that the coefficients as well as the constant terms are all rational numbers. Therefore, since it is a linear system, we know that each coordinate of a single point solution should be a rational number as well. Alright, in the case of the x-coordinate, we do have that rational number from the calculator's conversion feature, but the y-coordinate, we only got this decimal approximation still. Well, since we know that this y-coordinate is actually a rational number, we know that its denominator must be greater than or equal to 10,000. That's why the calculator is unable to convert it to a rational fraction. Okay, so let's write this down. The y-coordinate is only approximate. Alright, let's say a little more here. Since the system has all rational coefficients and constant terms, the y-coordinate must be rational. Thus, the denominator must be greater than or equal to 10,000 and is therefore exceeding the calculator's rational fraction conversion capability. Okay, so we have got that completed there. Now, lastly, let's take a look at part C, which is our check of this. For a check, we would want to make use of the original equations and see that upon substitution, our claimed solution makes each of them true. Alright, the left-hand side of the original equation, the first one, is 211x minus 319y. We'll see what that is on the calculator. The second equation, original, is 74x plus 187y for its left-hand side. Then we'll see what the calculator provides for the right-hand side. Alright, let's go to the calculator. Alright, here at the calculator, we probably could clear the home screen and take the left-hand side of the first equation. That's 211x minus 319 alpha y. Let's see what this gives. 22. Good, just as in the original first equation. Let's go to that second equation's left-hand side. 74x plus 187 alpha y. Enter. 117. Good. Also the same as the second original equation. Alright, let's record our results on paper. Alright, in the case of this first equation, the calculator arrived at 22, and that is the same as the original first equation's right hand side, making that a check. Secondly, in this equation, 117 was the result. That's the same as the original equation's right hand side. That's a check. This solution overall now looks good. Exercise 14. Let's look this over. This first equation, okay, we have this x divided by the square root of 3. That's still a constant multiple of x. Here, this term has got y divided by square root of 5, which is still a constant multiple of y. And there's a constant here. Alright, this first equation is actually linear. The second equation has a couple of square roots, but they're square roots of constants. So we basically here have an equation which has constant multiples of x, constant multiples of y, and a constant. It's linear as well. So indeed, answer to part A is yes. This is a linear system, two variable. Alright, let's go to part B, where we will try to solve the system graphically using the calculator. First equation, need to solve for y. We could subtract x divided by square root of 3 from both sides, and then multiply both sides by the square root of 5. That would give us y1 equaling to square root of 5 times 6 minus x divided by square root of 3. Alright, in this second equation, to solve for y, add x squared root of 2 to both sides, then divide both sides by square root of 7. We could have y sub 2 equaling to 8 plus x square root of 2 divided by square root of 7. And now we can go to the calculator. Alright, let's go to the y equals to edit screen. Our formula for y1 is the square root, second square root of 5. Let's put an end to that radical sign there. Navigate forward. Then parenthesis 6 minus x divided by second square root of 3. Terminate the radical sign by navigating forward, and then put on our other parenthesis to seal off the expression there. Okay, let's go now to y2, for which we have parenthesis 8 plus x second square root of 2 end of radical sign parenthesis divided by second square root of 7 end of radical sign. Alright, let's see if the standard coordinate system can be of help to us. Zoom 6. Okay, a single point of intersection is on the coordinate system right now. Let's go get it calculated. Second, calculate, intersect. Alright, I would like to see the calculator cursor before answering this question, so I will notice that right now it has an x equal to 0, telling me that if I move the cursor to the right, I should start to see it eventually. Okay, here it is. Now I feel better about saying yes to that first curve question. And there's our second curve. Yes. And guess. Okay. Right about there looks it. Okay. Now let's try to obtain some exact answers if we can. So second quit. X, math, fraction, go. No, it only gives back the decimal approximation. How about y? Alpha, y, math, fraction, enter. Same situation. Alright, well, then we will be recording decimal approximations rounded to 3 significant digits. Let's go to the paper and do just that. So we're going to say the approximate solution is 3 significant digits. So the x-coordinate 5.69, the y-coordinate rounded to 3 significant digits 6.07. Okay, cloud around this conclusive statement. Now, we need to explain why is it we only have this approximate solution using the TI-84 plus, not an exact solution. Alright, looking back at the original system here, we notice the coefficients here involve square roots of 5, square roots of 3, square root of 7, square root of 2. Alright, we have a lot of irrational numbers in this system as far as coefficients goes. Thus, we are expecting to see irrational numbers for both the x and y in a single point solution, like this here. Alright, so then we cannot expect the calculator rational fraction conversion to be providing us exact answers in this case, since the answers are not rational numbers to begin with. Alright, let's write this down. Since the system has many irrational coefficients, we expect the coordinates of a single point solution to be irrational numbers. Therefore, the calculator's rational fraction conversion feature is not able to record exact answers. Okay, now we have the check still remaining here. Let's get going on that. Part C. Check. Alright, as usual, we will go to the original equations, take their left-hand sides, and have the calculator compute them and see if it equals to the original right-hand side. So we have y divided by square root of 5 plus x divided by square root of 3. We'll see what happens there. Secondly, we've got, for our left-hand side, y square roots of 7 minus x square roots of 2. Let's see what happens there. Alright, let's go to the calculator. Alright, we might clear the home screen and start with the first left-hand side. Alpha y divided by second square root of 5 plus x divided by second square root of 3. Alright, let's enter 6. Alright, that's the same as the original first equation's right hand side. Great to see that. Let's go to this second equation's left hand side. Alpha y times square root of 7. Navigate forward to put an end to that square root sign, and then subtraction x second square root of 2. Terminate the radical sign, and let's go with enter. 8 equal to the right hand side of the original equation. Alright, we just have to record our results on paper and we'll be done. Calculated result of this sum was 6. That is the same as the original equation that we have. That's a check. The result of this second left-hand side is 8, and that also matches the right-hand side of the original equations. That's a check. And we apparently have a good solution overall.